lecture, I am going to start new topic of the computer aided process synthesis. So let's start. Chapter name is Synthesis of Heat Exchanger Network. Topic is pinch technology. So to study pinch technology concept, you should know few concepts. For example, heat exchanger. So heat exchanger, it is nothing but one type of a device which is used in process industries to remove excess amount of heat from hot steam to the cold steam. Second one is the heat integration concept. Heat integration concept is used to reduce energy requirement in a process industry. So this is nothing but heat integration concept, that is pinch technology. We will study this concept in this lecture. So let's start. So pinch technology is nothing but, you can see on the screen, by using pinch technology process integration we can find out minimum hot utility requirement, minimum cold utility requirement and heat capacity flow rate for the hot steam and cold steam. So in your exam this question can be asked for 7 marks. Find out minimum hot utility requirement and minimum cold utility requirement. So before that we should know some assumptions for the pinch technology. You can see on the screen, first assumption is process should be at a steady state. Second assumption, the process should follow first law and second law of thermodynamics. And third one is the flow of the steam should be counter current mode. So you should know what is the meaning of steady state. I told you in last lecture as well, steady state process is nothing but the process in which process parameter are not vary with the time. Second, first law and second law of thermodynamics means according to first law energy neither be created nor be destroyed, and according to second law heat always flow from the higher temperature to the lower temperature. And last one, flow should be in a counter current mode, means if there are two streams, that is the cold steam and hot steam, both should be in opposite direction. So this is nothing but about the assumptions of the pinch technology. Now you can see the question type that can be asked in your exam. Question is, for the process fluids as shown in the table, find minimum utility requirement and pinch temperature. Also show the cascade heat flow diagram. Consider delta T minimum is equal to 10 degrees Celsius. Now according to this question, you have to find here minimum hot utility requirement and minimum cold utility requirement. After that you also have to show here cascade diagram. I will introduce you about the cascade diagram as well in next slide. So here delta T minimum also given, that is 10 degrees Celsius. Now we will see here how to solve this question. So stream data also will be given in your exam like this. There are various streams are available. See on the screen, those streams are nothing but H1, H2, C1, C2, means hot steam 1, hot steam 2, cold steam 1, cold steam 2. After that source temperature, that is nothing but 180 degrees Celsius followed by 160 for H2 and 60 degrees Celsius for C1 steam, and for C2 steam that is the 30 degrees Celsius. These are nothing but source temperature and given in the degrees Celsius. After that target temperature, that is 40 degrees Celsius for the H1 steam, 40 degrees Celsius again for the H2 steam. After that for C1 steam that is a 220 degrees Celsius, C2 steam that is 180 degrees Celsius. And lastly flow rate is given, that is heat capacity flow rate. It is nothing but MCP and unit is kilowatt per degree Celsius. And for H1 steam that is 20 kilowatt per degree Celsius, for H2 steam 40 kilowatt per degree Celsius, C1 steam 30 kilowatt per degree Celsius and C2 steam 22 kilowatt per degree Celsius. Now how to solve this question? To find out the minimum hot utility requirement and minimum cold utility requirement. So first step is, you can see in the solution, you have to find shifted temperature table. So to find out the shifted temperature table, there are some rules. First rule is, you have to find out temperature for the adjustment, that is find like this, delta T minimum by 2 is equal to 10 degrees Celsius by 2 is equal to 5 degrees Celsius. This is adjusted temperature. Now we are going to add this temperature according to rules. We are going to add this temperature in cold stream and we are going to reduce this temperature from the hot stream, because we know that heat is transferred from the hot stream to the cold stream. This is nothing but heat exchange. So you can see here we are going to add here +5 in cold stream because heat is added into the cold stream and it is removed from the hot stream. That's why we are removing here -5 from the hot stream and adding here +5 in the cold stream. So you can see here, according to rules, you have to find that temperature, means how much temperature you are going to reduce or how much temperature you are going to add in those stream. That can be found by using this delta T minimum by 2, that is nothing but 10 degrees Celsius by 2 is equal to 5 degrees Celsius. Now this 5 degrees Celsius is the adjusted temperature. Now we are going to add and remove this temperature from the hot stream and cold stream. So you can see rules on the screen. First one is the +5 in the cold stream and -5 in the hot stream. I already told you why we are removing -5 and why we are adding +5 in hot stream and cold stream here. So you can see here, for shifted temperature table, by using those rules, I will get like this data. For the source temperature for H1 steam is 175, target temperature is 35. You can see here, this is in initial, in whatever the table is given in your question, that is nothing but 180 degrees Celsius, but we have removed here -5 because according to adjusted temperature, according to those rules, we are removing -5 from the hot stream and we are adding that +5 in the cold stream. So 180 is replaced by the 175. After that, here H2 is initially, that is 160, now it is 155 because we are reducing the temperature from the hot stream and we are adding that temperature in the cold stream. So 180 -5, that is 175, 160 -5, that is 155. After that 40 -5, that is 35, again 40 -5, that is 35. Next, for cold stream C1 and C2, now we are adding here +5. So here initially, in initial table, that is a 60 and 30, now we are adding here, that is new temperature for the source is the 65 for the C1 and 35 for the C2. After that, target temperature is for C1 is a 225, initially that is 220 only, now this is 225, and for C2 stream, that is 180 is replaced by 185. Means you can see here +5 is added in the cold stream and -5 is the remove from the hot stream. So this is nothing but shifted temperature table. This is your first step to solve pinch technology problem. Now you can see on the next screen, that is stream population table. Now how to find stream population table? So this is a stream population table. So first step here, see carefully, first column is the temperature, after that profiles, third column is a delta T, this is nothing but temperature difference. After that, this is the difference between summation of specific heat for the cold stream minus summation of specific heat for the hot stream. After that, delta H and surplus or deficit of the heat, and last column is nothing but extra utility. From this column you will get minimum hot utility requirement and minimum cold utility requirement. But how to solve this? So you can see here, we have in previous slide I told you how to find shifted temperature. Okay, now we are going to use that shifted temperature in this stream population table. So you have to write down here this temperature, this temperature you can see in this figure, first column, this temperature is nothing but shifted temperature, but here we are going to write this temperature in decreasing order. Decreasing order means we know that in shifted temperature table 225 is the highest temperature of the hot stream. Okay, so 225 followed by the 185, followed by 175, 155, 65 and 35. This is nothing but shifted temperature, but we have written here in the decreasing order. So first step is you have to write in stream population table in temperature column, all temperature you have to write here in a decreasing order, but this temperature value should be shifted temperature, means we have removed -5 from the hot stream and added +5 in a cold stream. We have to use that data only. Done. After that, how to draw this profile? You can see in previous slide, you can see here, now H1 stream. H1 stream means that is flowing from the 175 to 135, means source temperature is 175 and target temperature is 35, means 175 to 35 flowing from the higher temperature to the lower temperature, because we know that it is always flowing from the higher temperature to the lower temperature. So now I am going to draw heat profile, that is nothing but temperature profile for H1 stream. So from 175 to 35, now you can see in this table, you can see here 175 to 35. This is nothing but temperature profile for H1 stream 175 to 35. We have seen in this previous table, that is H1 stream is source temperature is 175 and target temperature is 35. Now second profile you can see, this is 155 to 35. You can see in this table 155 to 35. H2 stream is flowing from the higher temperature, that is 155 to 35 because this is a hot stream. Then after that cold stream moving from the 65 to 225 and C2 stream moving from the 35 to 185. So similarly we are going to draw profiles for H2, C1 and C2. So you can just see in this figure now. We have drawn first profile, that is for H1 stream 175 to 35. Now H2 stream flowing from 155 to 35. Both these streams are the hot streams. Now we are going to draw all these profiles for cold stream. Now you can see on the screen, for C1, that is nothing but cold stream, heat is flowing from 65 to 225, 65 degrees Celsius to 225 degrees Celsius. That's why arrow in upward direction, because heat is flowing from the 65 degrees Celsius to the 225 degrees Celsius. After that last profile for the C2, that is the cold stream, you can see here 35 to 185 degrees Celsius. Means I can just conclude here, that is H1 stream. First is the H1 stream, you can see on the screen, this is the H1 stream, this is H2, this is C1 and this is C2. H1 stream here heat flowing from the 175 degrees Celsius to 35. H2 is flowing from 155 to 35. C1 flowing from 65 to 225. And last stream, that is C2, flowing from the 35 degrees Celsius to 185 degrees Celsius. So this is nothing but temperature profile for all four streams. Now next one, next column, that is the delta T. Now we are going to find here delta T, that is temperature difference. So how to find here? You can see temperature difference between first stream and second stream, 225 minus 185, this is 40. So just write down here, first is empty because there is no previous before 225 there is no process stream, so we have to keep it empty. After that in second row you have to put here 40 because 225 minus 185 is nothing but 40. After that 185 minus 175, it is nothing but 10 degrees Celsius. After that 175 minus 155, you can see here 20 degrees Celsius. After that 155 minus 65, 90 degrees Celsius, and lastly there is 65 minus 35 degrees Celsius, this is nothing but 30 degrees Celsius. So this is all about temperature difference. So we have completed here three columns. First one is the temperature profile. First one is nothing but temperature, that is the shifted temperature, and we have written this data in a decreasing manner. After that temperature profile, this is for the H1 stream, this is for H2, this is for C1, this is for C2, and we have written here temperature difference. For example 225 minus 185, that is 40. Similarly we have calculated for all these streams here, that is 40, 10, 20, 90 and 30. Then after that next column, that is difference between summation of CPC minus CPH. This is heat capacity flow rate or mass flow rate for cold stream minus mass flow rate, summation of mass flow rate for the hot streams. Now how to calculate this? You can see here, this 30 comes from this. Just you have to just observe this profile. In this 185, in this row here is only one profile is there, only one stream is available there, this, and this is nothing but C1 stream, cold one stream. So you have to just take here specific heat related to this stream, that is nothing but you can see here. Now I have to write here summation of CPC minus CPH. So yeah, in this column there is the no hot stream because hot stream is not available. This is hot stream 1, this is hot stream 2. So these two streams are not available in this region. So CPH is equal to 0 because I am repeating, CPH is 0 because there is no hot stream is available. This is cold stream, hot stream is H1 this and this H2. This both streams are available in this region only. This is not available in this 185 region. So you have to consider here only C1 stream because C2 stream also not available here. So C1 stream is nothing but specific heat for the cold stream for C1, that is nothing but 30. You can see in previous slide, that is nothing but for C1 that is 30, means this is the mass flow rate for the C1 stream, that is 30, for C2 this is 22. Now we have to use for summation of CPC minus summation of CPH this data 20, 40, 30 and 22. We have to use this data. So be careful. For H1 I am going to use directly. So see here carefully. For H1 that is 20, for H2 that is 40, for C1 that is 30 and lastly for C2 that is 22. So I told you in first data there is the only C1 stream is available. So C1 stream you can see here C1 is 30, H1 is absent, H2 is absent and C2 is absent. Only C1 is present. So C1 is nothing but 30 kilowatt per degree Celsius. So I am going to use directly this data. So you can see here in the next slide, you can see here. So summation of CPC minus CPH for first stream that is 30 done because there is the no hot stream available, that's why summation of CPH is 0. Now second one you can see here, there are two streams are available, C1 and C2, H1 and H2 are not available. So C1 and C2 means just add heat capacity for this C1 stream and C2 stream. For C1 stream that is 30 and for C2 stream that is 22. I already told you for C1 that is 30 and for C2 is 22. So 30 plus 22 that is 52 minus 0 because CPH is equal to 0. There are no hot streams are available in this region. Only cold streams are available. So summation of CPC is 30 plus 22. For this stream MCP is nothing but 30 and MC for this nothing but 22. So 30 plus 22 is 52. Minus 0 is nothing but 52. Now next for 30 you can see here this 30 comes from this. There are two streams are available. Those are the cold stream and one hot stream is available. So summation of CPC means 30 plus 22 that is 52 minus this data. Now data for this stream you can see in the previous slide as well, data for that stream is nothing but for H1 stream that is 20 and for H2 is 40. So for H1 we are going to replace this or we are going to reduce this value for the summation of CPC. So for H1 that is 20 and for H2 that is 40. So 30 plus 22 that is 52 minus 20. 52 minus 20 is nothing but you can see here 32. You can see here that is 32. So similarly we will calculate for the next stream that is minus 8 means here summation of specific heat for this stream C1 stream plus summation of this C2 stream means specific heat for the C1 plus C2 minus H1 minus H2 you will get minus 8. For last stream you can see here there are only 3 streams are available, that is C2, C1 is not available. So C2 minus H1 minus H2 means specific heat or heat flow rate for the C2 stream minus H1 stream and H2 stream. You will get finally minus 38. Done. After that you can see here delta H. Delta H is nothing but MCP delta T. So MCP delta T you can see here. This is nothing but MCP value, flow rate, specific heat flow rate. So just multiply this 40 into 30. You will get here first data 40 into 30, 1200, 52 into 10, 520, 32 into 20, you will get here 640, 90 into minus 8, you will get here minus 720 and lastly minus 38 into 30, you will get here minus 1140. So this is all about delta H. This is nothing but sensible heat and you can calculate this heat by using MCP delta T. After that surplus or deficit means if there is any increase in heat or decrease in heat, you can calculate by using surplus or deficit values. So how to calculate this surplus or deficit? You can see here. So just here you can see minus 1200. Minus 1200 means this previous heat minus initial heat. Previous heat is nothing but empty means 0. 0 minus 1200 is nothing but minus 1200. Done. 0 minus 1200 is nothing but minus 1200. This is nothing but previous value minus initial value. Means you can calculate here minus 1200. For next you can see here this previous value is minus 1200 minus initial value. Means minus 1200 minus 520. You will get here minus 1720. For next value, previous value that is nothing but minus 1720 minus initial value means minus 1720 minus 640, you will get here minus 2360. Similarly, minus 2360, this is nothing but previous value minus initial value means minus 2360 minus 720 means minus 2360 plus 720 is nothing but minus 1640. And lastly, minus this value means minus previous minus initial means minus 1640 minus 1140. So this is nothing but minus 500. So this is all about surplus and deficit values. Now last column, that is nothing but extra utility. So how to calculate this extra utility? See carefully here. Before that you have to write here 2360. This is nothing but most negative value of the surplus and deficit. You have to write in first row that value which is most negative value in surplus or deficit column. So that value is nothing but minus 2360. Most negative value or very minimum heat requirement, that is nothing but most negative value. So that is 2360, and you have to just write this value in first row of the extra utility. So that is nothing but minimum value of the surplus and deficit, that is minus 2360. This is the minimum value. So just write down this value in plus like this, 2360 positive. Okay. After that, now you have to calculate extra utility. How to calculate these values? You can see here 2360, this value minus delta H means extra utility minus delta H. So 2360 minus 1200, this is nothing but 1160. For next value 1160 minus 520, you will get 640. 640 minus 640 is nothing but 0. After that 0 minus 720 is nothing but 0 minus 720 means nothing but plus 720. And lastly 720 minus 1140 is nothing but 720 plus 1140 is equal to 1860. So this is the calculation for extra utility. What we have done here, we have just reduced this value delta H value from the extra utility. So for first value 2360 minus 1200, 1160 minus 520, you will get here 640. Similarly, you have calculate all these values till 1860. Now you can see here in this table, in extra utility, one value is the 0. This 0 value is nothing but related to the pinch temperature. So pinch temperature, you can see value, this is 0. Temperature related to this heat, that is 0 heat, means temperature related to this point 0 is nothing but your pinch temperature. So pinch temperature is nothing but 155 degrees Celsius, and heat is nothing but 0. So this 0 is nothing but your pinch point, and corresponding temperature is nothing but pinch temperature, that is 155 degrees Celsius. And you can see here this plus 2360, this is your minimum hot utility requirement, and this 1860 is nothing but your minimum cold utility requirement. Done. So this is your answer. You can see on the screen now answers. Minimum hot utility requirement is 2360 kilowatt and minimum cold utility requirement is 1860 kilowatt. So this is the answer for this question. What we have seen in this lecture, I repeating now. You can see we have taken this question, and here delta T minimum also given. You have to find in this question minimum cold utility and minimum hot utility. So before that, in question this table will be given, that is nothing but stream data for the H1, H2, C1, C2. After that, we have calculated here shifted temperature. For shifted temperature, these are the rules which you can see on the screen. First, you have to find adjusted temperature. For that, you have to divide the temperature by 2, means you are going to divide that temperature in equal interval, that is nothing but delta T minimum by 2. Why we are dividing here by 2 only? Because we are dividing that interval in equal interval. Okay, so delta T minimum by 2 is nothing but 5 degrees Celsius, and according to rules plus 5 in cold streams and minus 5 from the hot stream, because we are removing heat from the hot stream. That's why we are here removing minus 5 temperature from the hot stream and adding that temperature in the cold stream. After that, we have find here shifted temperature, means just remove that plus 5 from the hot stream and add that plus 5 in the cold stream. So you can see here. After that, we have calculated stream population table. In this table, we have just written in first column temperature in a decreasing order. This temperature is nothing but shifted temperature. After that, we have drawn temperature profiles. You can see first row is first arrow is nothing but that is the for H1 stream, second for H2 stream, third for C1 stream, fourth for C2 stream. After that we have calculated here temperature difference. After that you can see here we have calculated here difference between specific heat for the cold stream and hot stream for all the temperatures. After that we have calculated here delta H values. After that we have calculated surplus and deficit values, and after that we have taken most negative value, means minimum heat, from the surplus and deficit column and just written in extra utility in this manner. After that by using cumulative manner we have just find out here extra utility, you can see here, and this 0 value is nothing but your pinch value, and corresponding this is your pinch heat, and this is corresponding temperature is nothing but pinch temperature, that is nothing but 155 degrees Celsius, and this heat, that is a plus 2360, is nothing but your minimum hot utility, and this is your cold utility, that is 1860, and pinch temperature is nothing but 155 degrees Celsius, because corresponding it is 0 kilowatt. So this is all about this lecture. We will continue next topic in the next lecture. Thank you very much.